Okay, thank you for coming to this talk that we will discuss automatic techniques around the continuous delivery to control and reduce as much as possible technical debt. So first, just a few details about me. I'm currently working on Walmart, and in fact, we are creating tools to reduce technical debt using automatic approaches. In fact, I'm considering myself as a best practice enthusiast or software engineering lover, because I have some papers and also some talks about it. And you can find me on Twitter on this name. So, and this is the logo of my product.
Yeah. Hello, my name is Alex. I'm a software engineer at Red Hat. You can follow me in several open source projects. And yeah, you can follow me on Twitter. I think that is the best way to approach me. Yes. At least it's fast. If you send me an email, I will answer it when I can. And in Twitter, it will be almost automatically if I'm not sleeping. And also, I'm the author of Testing Java Microservices and Apache Tomcat RefCard. So please, if you have any question, please just raise your hand and just answer it just at that time. So we have all the context. And the first thing that I would like to say is that, yeah, software is eating the wall. And I'm not talking about, like, for example, Google or Microsoft or, you know, any of these technical or technological companies, but companies that started to create a software model with a traditional business. For example, Netflix, for example, Airbnb, for example, Uber, all these companies are taking a traditional business and then just implement it as a software model. And let me share you one example. This is one really fun. This is Windows 3.1 is still alive, and it just killed a French airport. And you said, oh, okay, this is news from 95, but not, please check here, it's 2015. So, you know, 1 year ago, yeah, all the air traffic was managed manually during 2 days because of immigration of Windows 3.1. Another one, which is quite funny, is this. This is the $57 million slot machine win, blaming it on software error, casino won't pay. And at the end, yeah, I always think about that. I'm going to the slot machine, I put the coin, I push the button, and it's there, I'm rich. And then it said, no, you're not rich, sorry, there is a software error. So when we write software, it's, yeah, sometimes we don't care about these kind of things. And at the end, you can read here, it's really funny, say, they offered him $100 and a free meal instead. So it's really fun. You go to the casino, you think that you are rich, and then, oh, sorry, you have a free meal. So yeah, software. So actually, we will say that we need a faster way of deploying to production, maybe because our competitors are doing something, and we want to, you know, reach also faster. Sooner, because maybe there is a bug, like the slot machine or the French airport. So yeah, we need to fix it and release it as soon as possible. And of course, better in the sense of better software, in an automatic way, without manual steps, and so on and so forth. So yeah, we need some process to do all these kind of things. And obviously, one of these methodology or process to do it is continuous delivery. And I don't want to extend about continuous delivery because we can stay here talking for hours. But you might think that continuous delivery is a build tool. Maybe it's automated tests. Maybe it's a continuous integration system. Maybe it's, you know, reports or automatic deployment. Maybe you think all these things is continuous delivery. And maybe you're right, it's all these kind of things, but I think that the best definition about continuous delivery is that delivering business value more frequently. And this is the key of continuous delivery. Just put your business value as soon as possible to the final users. And basically you get this by defining a pipeline. Probably you've seen this pipeline in several places in different ways, but at the end it's always the same, where you develop something, you commit something to your SCM, you build your project, you run your tests. I mean, here it's commit tests, unit tests, integration tests, component tests, automated tests, I mean, all kind of tests. You put it to a stage. Then there is a deploy step, because we are talking about continuous delivery, which means that someone must say, yes, okay, this product is verified, so please put it to production. Then you put it to production, and then you start earning money and getting feedback from the users. So maybe you deployed something and the user said, I don't like this change, maybe it will be better in the old way, or trying to find another way. So you get this feedback, and then again you develop a new features and you get all the pipeline one and one again. Of course, this build must be synchronized somehow, because we've seen that there's several stages, and we need to orchestrate all of them to execute in a good way, in the best performing way, maybe parallelizing some tests and so on and so forth. And I think that the best solution, for orchestrating is Jenkins. And you said, well, it's an opinion. Yes, of course, it's my opinion. But there is this this polling that did my friend from Rebel Labs, and notice that Jenkins is 60% of penetration, and then the near competitor is not Travis, it's not Hudson, it's not Bamboo, it's we don't use CI. So I would say that, or we can say that the de facto tool is Jenkins, right? So, and basically with Jenkins you can do everything. It integrates with everything you can think about in any of the stages: deploy, release, scan, build, config, run tests, wherever. I mean that I would say that it integrates with everything. So how you define a pipeline? Well, in Jenkins, basically you have the concept of freestyle job, or a job, where you define which are the steps that you want to execute in this job. And then you chain all these jobs to build a pipeline. And for example, you have some kind of a stage which is called execute shell, where you, for example, here execute that you want to compile Java and you want to report the JUnit results and so on and so far. Probably all of you who has worked with Jenkins feels he has seen this window sometime. And that's okay. I mean that it's quite manual. You need to create jobs and create, execute shell, add build a step, execute another shell, and so on and so forth. It's okay. The problem is what's happened when we start with microservices, where we don't have a one monolith service, so we do this freestyle job only once for that project, but we have microservices where we have a lot of services. Then it means that you have to go to the Jenkins, create a new job for that service, do or construct all the pipeline. Then you need another service, you go to the Jenkins, you create again all the pipeline, and so on and so forth. So if you have like 100 services, you need to do this 100 times. This is a summary of what's happened with microservices. Each of the service is deployed independently. So it means that each of the service has its own pipeline. It might be all of them exactly the same or not, but at the end, you've got, or you need to define the pipeline every time. So probably you're saying, oh, please, no more jobs. Because if you have to do 100 services and you need to go manually registering one job is like a tedious job. So what you can see with Jenkins 2, it's something called pipeline as code, which basically what you define is your build as a Groovy script. Actually, you will not notice that it's a Groovy script because it's in fact, it's a Groovy DSL, but yeah. So one of the features of the pipeline ecosystem is that the configuration is in the source repository. It means that you have your service, and in the service, in your Git repo, if you're using Git, you have your pipeline there defined as code. It means less click and type and more code. since your pipeline is defined as code, you don't need to go to the Jenkins administration and go there, create a new job, add all the build steps, post build steps, and all these jobs that you need to do. It supports from simple pipelines to complex ones. It supports, that you can think about all the more complex pipeline that you might have and can be implemented as a pipeline. One of the great things that it has is that it survives Jenkins restarts and connection losses. Basically, what's happening if you're having Jenkins and you're running, your automatic tests, and then network goes down and the Jenkins is a stop. Okay, the build fails and you said, then I need to go again to the job, do play, and I'm going to compile again all the project, run all the tests again, and all the stages until you deploy again. But in case of Jenkins pipeline, for every command that you run, it persists at disk. So when you restart a job, it just simply checks if there is something in a disk, and if there's something at disk about that pipeline, it restarts from that point. This means that if you have for example, that your machine has go down, you can boot up again the machine and continue the pipeline where it was left just before the crash. And of course, since it's code, you can reuse that pipeline across all your services. So instead of defining one pipeline in each of the services, you can have your repository with your pipeline definition and just say to the Jenkins, in all these services, just use this pipeline. So you've got in one central place, for example, in Git, and all the services uses that definition. And notice that this means that since it's code, you can branch, you can revert, you can open issues, you can do code reviews, and so on and so forth. And the last thing that offers is that you can build the history and thread segregated per branches. So instead of saying, okay, I have the master branch and the future branch, and you need to configure for master branch one job, for future branches you need to define another job, and so on. In this case, it just you define the SCM URL, and Jenkins will start a new job for each of the branches that it has at that moment, and also the ones that you can push as a future branch. Let me share some example. In this case, it's a really simple pipeline which just runs the test and build or store the reports. The pipeline is let's say the root element, and then you do an agent any. This means that, as you know, Jenkins have an agent model that it's like the slaves. So you said, I want to execute this pipeline in any slave that I might have in my Jenkins infrastructure. And I have just one stage, which is called test, and it's going to execute these steps, which is Raquel check. And finally, when I finish all these steps, I create a post. It's not a step per se, but it's a post action that is executed always, which means that I report the JUnit results. This is another example which is quite better, because what I'm saying here is that it's exactly the same as before, but I said, please, the agent is a Docker. So it's going to happen in this case is that Jenkins will say, you want to use Docker? Okay, then I'm going to start the Maven Alpine Docker container. It's going to start, it's going to mount your workspace inside, and then execute Maven clean verify. And notice that as an argument, I'm passing the Maven local repo to avoid having to download all the internet over and over again every time that I try to build a project. And then, executes the stages, and that's all. And finally, this is quite more big. What I'm doing is a stage, then I do a post, then here there will be maybe some tests, and finally, now I said, if there is a failure, not always, just send an email with this address, with this subject and this body. And notice that since it's a Groovy script, I can use this notation of automatic placeholder resolution, passing the variables that you have like the current build or the environment variables. Also, another thing that you can do is just do a sanity check, which means that I want to be sure if this should be deployed to production or not, for example, and I do input and this, does this staging environment looks okay? And then if you do this, Jenkins will show you a pop-up, and you can decide if you want to proceed or continue the pipeline or just stopping it. And to define it, it's really easy. You just define a new pipeline, you put the git SCM, and that's all. Just with this, you're going to have all your pipeline running, getting all the information from your repo. And that's okay. So now we have all our microservices running, and all with each of them with a pipeline. But I don't know if you know the concept of 2 pizza teams. This is something that comes from Amazon, and it's like each team of a service should be composed by the amount of people that you can feed with 2 pizzas. If not, it's too big team. So you need to change the size of the team, split the team, or whatever. So now it's great because we have a lot of services, a lot of teams, and a lot of services there. And each of the team might have different practices or different ways of doing things. So what has happened is that Red Hat created Fabricate. Fabricate is a microservices platform that for developers. It's just focused on developers, not on the operational team, but just developers. And it's based on Docker, Kubernetes, and Jenkins. So the things that you can do is just create microservices using wizards. It provides wizards for Java, Spring Boot, Wildflower Swarm, Java EE, PHP, Go. I mean, that any of the typical languages you can get there, and you said, I want to create a microservices with a Spring Boot, and then it gives you the information, and then it automatically configures that service with a Jenkins pipeline for deploying to Kubernetes automatically for you. So when you create your project, you push a button, and magically your project is built and it's moved to or deployed to Kubernetes. When you want to release a new version of your service, you just push the button, and automatically Fabricate will roll back the previous service and put the new service there, and everything is managed automatically. And it's open source, and it can be installed on premise, on public, or on hybrid cloud. Just the requirement is that it works with Kubernetes.
So now it's my turn. It's true that that Fabricate can help you to define what are your conventions with the infrastructure part of your whole system, right? But we have multiple teams that are working in parallel in different services, and the only way that we can share knowledge is by code review. At that moment, if every team works in a different way and with different programming practices, what we detect is that in some way, in some microservices, we are starting to have technical debt, because not everybody knows how to apply good practices, good programming practices, right? And for that reason, we need tools that argument what are our internal opinions about what is right and what is wrong. That's true that technical debt is not only coding style issues, right? But currently, the only way that we can measure that is using static code analysis tools and also test coverage tools. And for Java, right now, the most common tools to measure the code quality are PMD, CheckStyle, Find Bugs, and Sonarqube. In fact, PMD is very well known because it doesn't require to compile your source code. It just parses what you have and detects common bad practices, code smells, in the structure on your code. CheckStyle is more focused on formatting issues, indentation, and right now you can choose if you want to apply Google programming style or even the previous well-known Sun coding style. And finally, we have find bugs that requires to compile the whole project and looks for potential bugs into the class files. And finally, Sonarqube, which was a solution that open source, of course, that started to integrating the other one solutions, and right now it's creating its own rule set. The main difference between Sonarqube and the other solution is that Sonarqube allows to work incrementally. Okay. However, if we are in a continuous integration environment, how these tools can be used from Jenkins. The common way to do that is if we are using a Git workflow, we check if these tools are reporting new violations during the build. Okay? And when the build fails, we need to work again into our source code and create another commit and launch again the build. But what happens when we have strong deadlines? Usually, these solutions are very good when we have time to work on it and when we detect that we have technical debt and we need to work on it, right? But especially when we are in MVP's projects or we have strong deadlines, being stopped by your Jenkins because there are common violations that can be easily solved, it's not a productive way to work on it. As a consequence, when we run a Sonarqube and we measure again our debt, that it's the amount of time that we need to fix everything, we have days. In fact, this is a real value, the current value of technical debt for the Struts 2 project. However, many of these kind of guidelines that are tested or validated by a static code analysis tool can be validated. Probably we are talking about 20 or 40%. In fact, the most common automatic rule that we are using as a developers is the organized import action of our favorite editor before pushing the source code, right? So thinking about it, I started an open source solution to fix those bad practices automatically. And well, you can say you can implement this as part or as a plugin of your favorite editor, right? But what happens in an environment like Jenkins? We cannot execute this kind of tools in a integration and in a continuous integration platform. So now that's easy to do from Maven or Gradle, just typing one mode patch as a value of our command line, and this produces a patch that we can easily validate if it's good for us or not. You can select if you want to create patch for PMD, find bugs, or Sonarqube. And the main thing is that we can easily validate what's changing because all our formatting options are respected. So Walmart is not reformatting all your source code after fixing whatever. You have defined it as your own rule set. And in this case, as you know, we are removing an unused import, also an unused attribute. We are solving, for example, the usage of final parameters, that is a common issue that open source asks for it when people ask what I can do for this open source project. And for example, a common rule of PMD is simplifying if statements. If we have one if statement inside another and there is no an else condition, we can rewrite this condition as just one. And how internally works Walmod? Walmod is very similar to the existing static code analysis tools. But one important thing is that it has what is called semantic analysis in the world of compilers. And what does it mean? That Walmod is able, using your class path, to resolve the symbols in your code and then the types of each expression, and then when a symbol is used or not. And this famous organized import we can write with just 3 lines of code. In fact, Walmod was started like a framework to run code transformations. It was a generic concept, and now we are focused only on fixing existing rules that others have thought that are interesting to have a clean code. And the most important thing, when we apply changes, these are the minimum changes that we need to write in the final source code. So for example, if we are in the same line using tabs or spaces, the next lines, if we need to add new methods, we'll use the same combination. So it's learning what it's doing in every single file. There is a discussion about this kind of tools, if you can trust on them or not. In fact, what is surprising is that when we are working in a legacy code base, formal companies prefer to trust in tools than in people, right? Because the controlled changes, as they are developed as open source solution, they are already validated. Whereas people just can write, well, errors that are not voluntarily produced. However, my personal recommendation is to always have test coverage. In that way, you can simply trust the tool and see if your confidence is good or not. So, talking again about automatic approaches to fix things, what we run after we configure our POM-XML with a Maven plugin for Walmod, we just run Maven Walmod patch, which produces the Walmod patch file, and then we can easily apply it into a repository with Git, and then validate if these changes are correct or not. Afterwards, in fact, Git has a special flag to report this kind of commits. Okay? That is the fix app. And finally, what we need is to integrate our changes into our current branch. Now that we have a receipt, we can integrate it into Jenkins using pipelines, right? And the most important thing is that in this commit, we don't need to stop to fix our own conventions. And if we are in the context of microservices and we start from scratch, we always will have clean code without effort. Specifically, we have built a Jenkins pipeline library in order to avoid to repeat again and again the same instructions in every single build. And you can freely use from this GitHub, okay? And then you just need to put here the reference, anything more. And finally, what we need is a special step to fix code conventions. And that's a simple call to Walmod apply. And internally, that's what we have seen in the previous receipt. And we can define different behaviors that we can parameterize here. But the defaults are, if we want to validate the patch before applying it into our Jenkins, the branch where we want to push the changes, and if always want to apply the change and build and fail the build. Because if we fail the build, since we have committed again some changes, if we have our Jenkins properly configured, it will launch again a new build that successfully will end. Yes, you just need the one-apply invocation in your build, right? But internally, it's using other calls that are in the same repository, and you can freely use instead of using the main call if you want to implement your own behavior with this kind of fixing tool. The others are has one mota patch that internally invokes the Maven goal to generate the patch, and then the integration methods that applies the patch into our Git repository and pushes the changes. So let's see in a live demo. Testing? Okay. Vale. No. No, okay, right. Yeah, we have used Gox in this case to store our repository that is a open source solution built on Go, very similar to GitHub. So here, what we have is a file that is the PMD configuration in this case that is checking the same conditions that you have checked before. Unconditional if statement, collapsible if statements, unused private fields, unused imports, and method argument could be final. And here, our Jenkins pipeline we have this step and the next one, which also checks if PMD is reporting new violations, right? Now, I have here the project, and if I run PMD check, we have here the violations produced by PMD. And now, if I run, so here is the project that I have commented before with the OneMode API. Here is the configuration to use the pipeline in Jenkins. And now, if I run the build, now it's running OneMode, which is that allows to create our own plugins and then our own quick fixes with our own practices. Walmart, as I said, create a semantic analysis, and for this reason we are building here the project, because we need the class path. Now has front, and here is asking for if I want to validate the patch. And where is the patch? We have printed here the patch. So we can decide if we want to just continue or not. And in this case, we have defined that at the end, the build always will fail, right? Exactly. So now, if I come back to the project, well, you can navigate. Well, let's go in the old view, because the other one was the Ocean Blue plugin. If I check in my build, I have here the report about the last changes that we have submitted to continue. And then, if I run again, we will see that now there are no pending changes to add, and finally the pipeline will be green. And the most important part is that we are checking PMD again, because this step, you can never forget to do that, because there are some rules like the lack of documentation, maybe, that cannot be automatically performed, right? So if you want to conserve this kind of rules, you need to check, again, this static code analysis tool. But the automatic part that it's valuable always that we have starting a project makes sense when we don't have time to invest on it. So yes, we have a green color, and now if I upgrade my repo, I have a new commit here with this prefix fix up that has been automatically created by Git for this flag that we have commented before. Okay, that's true that Walmart is useful when we are starting a new project and we want to have a minimum of quality in our code base, right? And the important thing is to start from the beginning, because in that way we will get incremental patches, always. But what happens if we have a monolithic application, okay, and we want to add quality in a fast way? The main recommendation is to add it incremental way, not because you cannot trust in the tool, just because when you need to validate your changes during the code review, having a big patch is not useful. You cannot understand everything that has been changed and then just trust or not on these changes, although you have complete test coverage. In fact, when I was working with these automatic changes and discovered which is the opinion of open source projects to adopt these kind of tools, I started to create big patches according to their own conventions. And just, I was asking if it's useful or not, because I was completely convinced that this patch of my pull request will be accepted. But this is what I commented before. When you have big patches, since code review just need to take less than 20 minutes, because the main purpose is to spread the knowledge, you cannot validate lots of things, because maybe one of these lines is removing some text, and this patch that it's so big, you cannot detect things like that, right? For this reason, we have built a OneMod Hub tool that you can freely download. It's a Docker image. And you will see all the possible patches that you can apply for each rule of PMD, and then fix it automatically. Also, you have metrics to control if you are improving or not, or the amount of work. In fact, we are doing some bonus for those users that, for example, are removing code that has some issues, or are just investing on fixing existing code to make it better. So it's a kind of gamification. And also, what you can also do is invest the quality of each commit. And the most important thing is that you can prioritize what are those issues that you need to fix, because belongs to the host, the hot files that you are continuously changing. And these files are what matter most for the business. So that's all for me. If you have any questions, so just raise your hand. Well, no. The rule in this case is checking in case that the variable is not final and is not modified, put final. But the code always needs to be compilable. Yeah. Exactly, yeah. You can configure exactly which files you want to process and then manipulate to finally fix. Yeah. Opinions? Well, yeah, exactly. Just for one line. No, you just can invalidate a specific rule. In fact, you need to configure which is the engine that contains the rules that you want to fix. And right now there is a subset of these rules implemented. Let me show you how to set up OneMod in your POM XML, because maybe it can help. In this case, I'm setting here in the properties, which is the engine that I want to use, that is PMD, okay? And here I'm setting which is the rule set of PMD that OneMod needs to interpret to understand what are the fixings that they need to apply. And that's all, because the other part consists of just adding the plugin. And in Gradle is exactly the same. How many of you have used static code analysis before? Awesome. Right. Currently, there is support for PMD, few transformations of CheckStyle, and also Sonarqube. In fact, Sonarqube I think that it's one of the plugins with more transformations that was initially created by a company that was, the name was Metric Stream. Well, you just need to pass the same configuration as you have in your static code analysis tool. And then Walmart tried to use as much as possible. But the Walmart also is a command line tool, and you can manually set the list of transformations that you want to apply. But in this case, it's more complicated because you need a special configuration for Walmart. But you can do that, yes. No, in the case of Sonarqube, Walmart connects to your Sonarqube server to get the rules, and just run the rules that it's able to fix. Yeah, you can. For each rule, there is a transformation, and in this case, you need to set from a command line Walmart add this rule, because you can in the documentation you can inspect the plugin, see the amount of rules that are implemented, and then you just need to Walmart add this rule, Walmart add this rule, and it generates an XML file that Walmart will take in the execution if it exists. If not, it's using what you are configuring here. Yeah. You can also implement a fixing for this rule with a pull request on the plugin, because all the plugins are open source. So that's all for me. Thank you very much for listening.